Do stronger math scores in high school translate to better GPAs in college? We know ACT math scores can be a signal of academic readiness, but do they actually predict success once students get to college? We often assume that students with stronger math skills are better prepared for college, but is that actually true? Let's say we divide students into low, medium, and high ACT math categories. Can we say those groups perform differently when it comes to first-year GPA? To answer that, we'll use a one-way analysis of variance. Our research question is, do students with different levels of ACT math scores have significantly different GPAs during their first year of college? We're comparing more than two groups on a continuous outcome, which makes this a textbook case for a one-way analysis of variance. Here's how we decided on one-way analysis of variance. Our dependent variable is continuous, first-year GPA. Our independent variable is categorical, ACT math category, which has 3 or more levels, low, medium, and high. We want to compare mean GPA across these independent groups. Since we're comparing more than two group means on a single continuous outcome, and the groups are independent, we use a one-way analysis of variance. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses. Then we want to define your variables clearly. What's the outcome? What's the grouping variable? And how are they coded? From here, describe your data preparation steps, including how you filtered, recoded, and structured the data. Next, want to explain the method you're using and how you calculated or entered group proportions. We should also mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. The one-way ANOVA tells us whether at least one group mean is significantly different from the others. The test produces an F-statistic, which compares the between-group variance to the within-group variance. Between-group variance is how much group means differ, and within-group variance, how much students differ inside each group. And it gives us a p-value, which tells us whether the variation between group means is too large to be due to chance. If the p-value is less than 0.05, we conclude that at least one group is significantly different, but we don't yet know which ones. For that, we'd follow up with post-hoc tests. Before we can run the one-way analysis of variance, we need to convert the ACT math score into a categorical variable with 3 levels: low, medium, and high. Here's how to do that in SPSS. Go to Transform, then Visual Binning. Select ACT Math Score, and click Continue. Click Make Cut Points. Choose equal groups based on values. Set the number of cut points to 2, which gives us 3 bins. Click Make Labels, and it will tell you the ranges that qualify for each. We can relabel these if we like. Then we want to name the variable, which I called ACT bin with an underscore, which is how SPSS is going to read it. Click OK. And now you've created a new categorical variable that splits students based on their ACT math performance. Here's how to run a one-way ANOVA in SPSS. Go to Analyze, Compare Means, One-Way Analysis of Variance, or ANOVA. Move GPA to the dependent variable box. Move ACT math category to the factor box. If you want to know which specific groups differ, click Post Hoc and choose a method like Tukey or Bonferroni. I prefer Tukey, and it's nice because it's a name that's easier to pronounce. Click OK. SPSS gives you the F-statistic and p-value, and if you added post hoc tests, you'll see which pairs of groups differ significantly. If p is less than 0.05, we say there's a statistically significant difference in GPA between at least some of the ACT math groups. But now we need to know where the differences are. And although they are intuitively obvious to the casual observer, we still want to appreciate the level of magnitude of these differences. Now that we know there's a significant difference in GPA across ACT math categories, the next step is to figure out where those differences are. To do that, we run a post hoc test. It compares all pairs of groups while controlling for the increased risk of false positives from multiple comparisons. We already ran this as part of our analysis, but out of this post hoc, we have each pairwise comparison: low versus medium, medium versus high, etc. The mean difference, whether that difference is statistically significant, tells you exactly which ACT math groups differ in GPA and how big those differences are. The two key post hoc tests that the three ACT maths groups differ significantly. In GPA, students in the high versus the low ACT math category have a difference in average GPA of about 0.7 points, and the difference between the low and the medium is about 0.3 points, so we can see the magnitude and differences between them. That means ACT math isn't just a loose indicator. It meaningfully stratifies GPA incomes in the first year of college, and that's the one-way ANOVA, your go-to method when comparing three or more group means on a continuous variable used here to test whether math readiness predicts college performance. We saw a strong result. GPA does differ across ACT math levels. Next up, we build on this by adding a second factor and testing for interaction using a factorial analysis of variance. Hit that subscribe button and let's keep asking better questions with data. Stay curious.